Hello, everyone. In this lecture, we're going to review the basic rules of arithmetic. We have learned the rules for addition and multiplication, but here I'm going to put them side by side to extract the common properties of those. So let's look at these rules. So the first rule we're going to look at is called commutative property. For addition, I'm going to put here addition. It means that A plus B equals B plus A for any two numbers. Of course, here we're going to focus on real numbers. So the result of addition A plus B equals the result of B plus A. So the result is independent of the order you're adding. And there's a similar rule in multiplication. A times B. In here, like just to distinguish from multiplication from the X symbol, I'm using dot to mean multiplication. A times B equals B times A. This is known the commutative property. The second property we have learned is called associative. And here it means that A plus B plus C, with the order priority, we first do the summation of the first summation, A plus B plus C, right? The associative property says that instead of I do A plus B plus C, the same result, it's going to have the same result if I do B plus C first. So A plus B plus C. So I can associate the B with A or associate the B with the C. It's going to give the same result. Similarly, for multiplication, we have A times B times C. In here, we're doing the multiplication of A, B first, is going to equal A times B times C. So in here, I can associate B with a C first. This is called associative property. Now, together, combining the commutative property and associative property, it really means that if I'm adding a lot of numbers together, let's say I plus B plus C plus D, it does not really matter which order I'm going to do the addition. I can do is the same as A plus D first, and then do B plus C like that, right? It does not matter. We're going to apply associative, commutative. Maybe we do the commutative first, move the D first in front of the B and C, and then we associate B plus C and A plus D. So this works. Similarly for A times B times C times D, it does not really matter which order we're going to take first. We can do A times D times B times C. We can do even this, and then we do this, and we do this. Does not matter. So this is very useful. So for example, if we look at the following problem. Let's see, if we have 1 plus 2 plus 3 plus all the way to 100, we can do the addition 1 plus 100 first and 2 plus 99 second. This way we can have those partial sums being a same number. 1 plus 100 plus 2 plus 99 plus 3 plus 98 plus all the way to 50 plus 51. The beauty of this is every little sum in here is the same number, 101. In here, we're using the property of commutative. First, we move the 100 front, so we can combine 1 and 100. And then we use associative. In here, we associative 2 plus 99 and 3 plus 98, so on and so forth. And this is 101 plus 101 plus 101. How many such 101s? If you look at the index, the first one, 101, is associated with the 1. The second one associated with the 2. The 50 ones associated with 50. So there are 50 such things. So 50 times 101 equals 5050. That's the sum. Or in multiplication, let's look at an example as well. Let's say how we calculate 2 plus 8 plus 5 plus 125 quickly. A normal way is we're going to do 2 times 8 first, and then times 5 and times 125. But because of these commutative property and associative property, I can change the order. Let's using dot instead of times. 2 times 5, and then times 8 times 125. The reason I'm doing this is each of these products is going to be a very simple number. 2 times 5 equals 10, times 8 times 125 is 1,000. So this whole thing equals 10,000. All right, so this is the commutative property and associative property. And often we take these and granted. Now for real numbers and for even complex numbers, this is all true. But as we advance to more advanced math concepts, this is not necessarily true. All right, so these are commutative property and associative property. And the next property we're going to look at is combining the addition and multiplication. And this is called distributive property. This property says that A times B plus C equals A times B plus A times C. This basically says that when I have A times something B plus C adding together, if we take off the parentheses, we need to times A to B and times A to C. So the A has to multiply to the B and to the C, and then we're adding the two products together. Now, this property is useful in both ways. Let's look at an example of going this way first. Okay, example 3. Let's say we want to calculate 32 times 56 plus 32 times 44. Let's using dot to represent the multiplication. Usual way is we're going to multiply this first, and then multiply this first, and then we add together. But if you're careful, you notice that it has a 32 as a common, so to speak, factor, right? So you take the 32 out. If I apply this distributive property, because we have treat A as 32, choose 32 as the A. So 32 times 56, 32 times 44, can take the 32 out, and inside we're going to have 56 plus 44. So 32 times 56 plus 44. And this turns out to be a very nice number, 32 times 100. So equals 3,200. So this distributive property gives us a very, very useful tool of calculating things in a neat way. Now, we also can apply the distributive law in this direction. And this is fairly common of taking out parentheses. For example, I want to calculate 2 times x plus y plus 2x minus y. All right, if we're going to take the 2, multiply into x and y, we have 2x plus 2y, and then the 2 inside, using the distributive law this way, 2x minus 2y, and then we're going to use the associative law, commutative law and associative law. We're going to change the order of how we're going to adding things. So 2x plus 2x plus 2y minus 2y, and 2y minus 2y is 0, so you will get 4x. Okay, so we talked about a addition and multiplication of commutative, a plus b equals b plus A, or A times B equals B times A. Associative, A times B times C equals A times B times C. And the similarly, A plus B plus C equals A plus B plus C. And distributive law. Now you say this is like true for plus and multiplication, plus and multiply. How about minus, subtraction, and division? Now in general, that rule does not apply. Commutative A minus B is not going to equal B minus A. But the trick is, if you're treating this minus B as a number, so A minus B as A plus minus B, then if you carry around the minus B as a number, then the commutative law works, right? So we're going to kind of get rid of the minus sign, treating this as a plus of a negative sign. Then the commutative, of course, works. So A minus B equals A plus negative B. This equals negative B plus A. Similarly, division, A divided by B. If you treat this one as A times 1 minus 1 over B times the reciprocal of B, then all those commutative associative law works. So we just ignore the minus and division as, you know, addition and multiplication, and that all the rule works. So that would be this video about the basic rules of addition and multiplication.